Okay, guys, first thing I want you to do today is this. In your calculators, I want you to know or see if you have some buttons in your calculator that can help make this be easier for us today, but we've got to have some buttons that we're accustomed to. So, what we'll do is make that work for us. Okay. Here we go. All right, here we go. Guys, I have a question for you. What is, let's make this easy for you. What's 2 to the 5th power equal? 32, right? Okay. So here's what we're going to do today. We're going to kind of work backwards to say, okay, we're going to say, this is kind of like saying 2 is the 5th root of 32. So if I wrote something, you guys, how many of you guys have seen this sign before right here? Square root sign. You know what that is, right? Okay. How many of you seen a square root sign, instead of having nothing up here, it has like a number up there like that? Have you seen that before? Okay, so this would be kind of new today. Here's what we say, kids. What we would do is we would say the 5th root of 32. Anybody want to guess what this equals? 2. Okay? So this is kind of like saying what value multiplied 5 times, what value multiplied 5 times together makes 32. And that value multiplied 5 times together is what value here? 2. So what we need to do is make sure we're able to evaluate different roots in the calculator. Now guys, we'll talk more about those indexes up there, but do you guys have a key that looks kind of like, oh geez, do I even have it up here? I'm not sure I even have it up here. A second for mine. Okay, do you guys have a button that looks kind of like this one right here, where it's got like a root, and then it's an X down here, and then it has a Y up here? Do you have that right there? Okay. I think what we need to do, what you need to do, I think, I'm going to try mine. Type in 32, or you guys might have to hit, gosh, how is this going to work? I don't know. I'm going to try mine here. I'm going to go 32. I'm going to hit this Y root X button. What root did I want? The 5th root right here. What's it kick out here? Okay. So what I want you guys to do is to see if you have a button in there that gets you the 5th root of 32, and what should it equal in the end, kids? 2. Okay, so are you guys getting that?
Yes.
How about you? You're good on that, 5th root of 32. Are you good? Getting it? Austin, good? Logan, did you get 5th root? Stacy, you're good? Allie. Corbin. Dave. You get it? Sam, you getting it?
In this one, maybe like it's, maybe I'll hit 5 first. For like the root, and then second, you hit that. Second, yep, that one, yep. And then 32.
Okay, are you good on it? So I think you guys are all good on calculators for roots. That's going to help you. So was everybody able to figure out how to type in the 5th root of 32? You all have different calculators? Where are my iPhone calculator people at? You guys are all good with that? Okay. Alexis, did you get it on yours? Okay. Sam's good. Gage, you're good? Okay. All right, well, let's roll. We're going to need the calculator today. But guys, we're going to start talking about what's known as radicals and rational exponents. All right. In the last section, all of our exponents were whole numbers like this. Okay. But now we're going to start looking at exponents that are kind of like this. We say that that's rational because it's written as a fraction. This is like x to the 7/3 power right here. We're not going to have a whole number out here anymore. We're going to have some kind of a fraction, right? And there's rules for that. And really, these rules Gotta be honest with you, they're not too difficult today, okay? So what this title is called is Radicals and Rational Exponents. Question today is how can you write and evaluate an nth root of a number? Here in this example, we were looking for the fifth root of what, kids? 32, which was? 2, okay? And it just means 2 times itself, how many times? Is? Okay. So we're going to touch on the basics of this section today. It shouldn't take us too long, but our job, find nth roots. That's kind of what we did over here. We're going to evaluate some expressions with rational exponents. Rational exponents means they're kind of like a fraction for an exponent. So I might say fractional exponent here. Okay. And then we'll look at some real life problems involving some rational exponents. A couple of examples there to end the lesson, so I don't think this is going to take too long today. All right? So let's talk, kids. Nth root of a right here. All right? This is kind of a weird font that showed up here, and I apologize for that. But it says, for an integer n greater than what, kids? 1. It says b to the n is equal to a, then it says b is what? Nth root of what? A. Okay, so I'm going to write this down here. If b to the n equals a, then what that means is this. So if this is true, then this is true right here. That means if I have some value a, and I take the nth root right here, this would equal what? Anybody want to guess what I'm going to throw in there? B. All right? Okay, so basically this is saying if the top is true, then the bottom is true. So let me throw something over here on this side. Let's just tell you that, I don't know, how about 3 to the 4th power is equal to 81? Then this would mean that the 4th root of 81 is equal to what? 3. Does that make sense? And by the way, 3 to the 4th is 81, so the 4th root of 81 is like saying, what number would you multiply 4 times to get 81? What number would you multiply 4 times to get 81? Well, that number is 3. And if you punch the 4th root of 81 in your calculator, guess what it's going to kick out? Absolutely. Okay. Guys, a radical. A radical is an expression that has basically this root sign in it. Okay? It's going to be an expression of the form where you have this radical sign in here. So which of these expressions up here is a radical expression? First one or second one? Second one. Okay? So an example might be the 5th root of 32. That is a radical. Okay? That's pretty cool. That's a radical. And it's pretty cool. All right, let me stop. We'll wait till they start Thursday. Okay, index of a radical. Okay, it says the value of what, kids? In the okay, so in this expression, 5 or the 5th root of 32, what number is going to represent your index?
5.
Your index is 5. Now, guys, you've seen square roots before. If I would write down square root of 64 like this, kids, I have a question for you. Are you ready for the question? What's square root of 64?
8.
8. But guys, what's the index up there? How many 8s does it take to make 64? 2 of them. I don't write the index up there. So if you don't see an index up here, the index is really what value? Okay, if you don't see a number up here, that implies that your index is 2. We're looking for the square root, or the second root of 64. Okay? All right, so there's a core concept here that we'll talk about. We're not going to, and you can refer back to it. We'll read through this here, and I think this will make total sense. I think vocab-wise, if you're okay with the vocabulary today, I think this is going to make total sense. So are you guys okay with these examples over here as they relate to the definitions? Okay, so let's chat core concept. Okay? This is just talking about nth roots of an integer. Okay? It says let n be an integer greater than what here, kids? 1, and let a be a real number. So if n is what? Odd, then a has one real nth root, all right? What I want you to understand out of this is the following. This here, pretty important stuff, all right? If I would write, this is kind of like saying the nth root of a is equal to a to the 1 over what here, kids? N. So if I had the fifth root of x like this is the same as x to what power? X to the 1/5 power, okay? So if I would write something like this over here, for instance, I don't know, if I wrote down 7th root of p right here, this would be the same as p to what power, kids?
1/7.
P to the 1/7. And I'll talk to you about what that means here when we look at more examples. But there's a concept out there that says if you have an nth root of a, that's equal to a to the 1 over n. All right? Then it says if n is even and a is greater than 0, then a has what, kids? Two real roots. I'll talk to you more about that. You remember that square root of 64 I talked about? And you guys told me it was what? But it'd also be negative 8. Could be, right? Because negative 8 times negative 8 is. Okay, so what they're saying right here is this. If your index is ever an even number, and this value down here is more than 1, how many solutions do you really get here? Okay, so if this index out here is ever even, you're going to have how many solutions? 2. Let me ask this question. How many solutions would this have? I don't know. My index odd or even?
Odd.
So I'll only have,
1.
well, what if I did this? How many solutions will that have?
2.
Because my index if here is even. Now keep in mind, this number underneath the radical sign has to be more than 1. Okay? Sometimes they're going to start throwing negatives in here, and I'll talk to you about that in a second. All right? But it says if a is even, or I'm sorry, if n is even and a is greater than 0, then this has how many roots, kids?
2.
Okay, I'm going to put this up here. I'm going to write this as the following, and maybe this will help you. If I have a positive number under here, and my index here is, I'm just going to put even up here. Okay? If I have an even index for the root of a positive number, this will imply that there's always 2 solutions there. There'll always be 2 solutions. Okay? Guys, if you ever have the nth root of 0 right here, what number times itself is going to make 0 all the time? It will always equal 0. So if 0 is ever under here, it's going to equal 0. That's pretty easy. Last one's kind of a tricky one. It says if n is even, so n is what kind of number?
Even.
But a is less than 0. In other words, b, what kind of a value? Negative. Then there is no root, no solution. So if you ever have a situation where you have an even index here, and your number under the sign is negative, there will be no solution. Okay? Now again, you guys have your calculators, right? And you know how to put roots in your calculator, so this should help. The one thing that you're going to struggle with is your calculator is only going to pick out one answer at a time. Well, it always pick out both answers. The answer would be no, because it's going to be possible where you have 2 solutions up here. And we'll look at some examples. What questions so far? First page. Got the definitions in 4 kind of written down, summarized. Let's see if we can make sense out of what's up here, definition in 4 ways. Okay. This here says find the indicated real nth roots of what? A. All right. Well, let's do this. Okay. This is like finding which root, kids? Third root of what? So when they write it this way, this is the same as saying, well, we need to find the third root of negative 64. So hop into your calculators and see if you can evaluate that. Third root of negative 64. And what I want you guys to do, maybe I should tell you this. Anytime you have a negative down here, put it in parentheses like that for me, okay? So you're going to type in the third root of negative 64. When you guys get that, punched in. Tell me what your solution is looking like. What are you getting for a value there, kids? Fourth root of negative 64. Did you? Oh boy. Get negative 4? Negative 4 is correct. Let's see what function in there. So it was 60, or is it a third? You put in negative 60. Put in 64, negative. Okay, now get your root button and 3. There you go. Good with that? Okay. What are you guys getting when you punch that in? Is there anybody that did not get negative 4? Everybody got negative 4? Okay. So guys, this is going to equal negative 4. Do me a favor, change this index to 4 up here. See what the fourth root of a negative number would have been. See what the fourth root of negative 64 would have been. What do you get? Domain error. That's that deal where, and the reason is, if it's even, guys, if you have 4 numbers times themselves, let's just start out. What's a negative times a negative for the first 2? Times a third negative would be negative, times a fourth negative would make it what? When your index is even like that, when you start multiplying negatives together, even amount of negative numbers multiplied together turns out to be a positive. So it turns out the only time you can ever evaluate a root when it's negative is if this index is odd or even. Well, it has to be odd up here. The only way you're going to get an answer out of odd. If this was even, then you would have said no solution. Okay? Let's talk about this one. How are you going to write an answer for this? How would I write this as a radical first? What root? Okay? You got to be careful on this. What is the square root of 81, guys? 9. But this goes back to that rule up here. It says, is my index odd or even? If your index is even and you have a positive number down here, you really have not just one solution, but you would have two solutions, because what else is going to work here? Yeah, so you put plus or minus 9 on that. Okay? All right, example 1. You okay with this? If I say find the nth root of a value, can you do it? Okay. Well, you guys then want to make sure we're good on these right here. We're going to do A and C together, but well, let's do them all together. What the heck? Guys, see what the fourth root of 81 is there. See what you get. How much? 3. Okay. Is 3 going to be my only answer? Okay, take a look at this. Is this is this index odd or even? Even up here, and so okay, should be, this is more than one, so a positive or a negative. All right. Now, this one right here is saying, suppose I covered that negative sign up. Wouldn't this be plus or minus 3 right here again? Well, which one do they really want you to have here then? They want you to have the negative part here. So this one here would just be the negative 3. If they wanted you to just have the positive one here, what should they have put out here? Put a positive out there, but they didn't, so they didn't even have both of them. All right. Okay. When you see 25 to the 1/2, kids, this is the same as anything to the 1/2 power is the same as square root of 25. What are you going to get for that? Okay, 5 my only one. What else could work? Yep, positive or negative. This is even, this is a positive. Even, positive. Just tell yourself, if the index is even and I got a positive number down here, there's going to be 2 solutions, positive or negative. Now this next one is goofy, because this is saying really take which root, kids? Or square root of, negative 25. Punch that in. What's it say there? Domain error. If I go back to the core concept right here, guys, it says if I have an even index and what kind of number underneath the radical sign? There will be no solution. All right? So here's what I want to ask you guys first. In terms of your calculator, give me a show of hands. How many are okay punching that stuff in? Okay, everybody good? Figure out their calculator, how to punch those nth roots in? Okay. Are you okay? I'm looking back at the core concepts here saying, okay, do I have two solutions, just one solution, or no solutions? Are you okay with when I say if you have an even index and a positive number, you'll have how many solutions? And if you have an even number and then what? If your index is ever odd, you're always going to have one solution, okay? Even index is either going to be two solutions or zero solutions. All right, great, kids, you're doing this. This is pretty easy, isn't it? Okay, well, let's talk about this next one. This next one, this core concept gets a little trickier. This one's pretty important, all right? Okay. This one here says let a to the 1 over n be the nth root of a. And let m be a what, kids? All right, what this says is this, and you can read it on your paper. It doesn't show up the best here, a little blurry, but this says a to the m divided by n is equal to a to the 1 over n all to the m power, which is really the nth root of a all to the m. And that sounds confusing, right? So let me just put this in a way that you can understand this, all right? If I have something like this, if I have a to the, I don't know, somebody give me a fraction. Let's go, no ones in it.
2/3.
2/3, I like 2/3, okay. All right. Let me show you this right here. Guys, when I wrote this up here, kids, 7th root of p, that was p to 1, what? Okay. Which number in this exponent over here, the top or the bottom, is my index? The bottom number will always be your index for your radical, okay? So here's what I'm going to get at. This is the same as, what number would be the index in this one, kids? So this is the same as the 3rd root of a. We figure that out. And then take that to, the top is always going to be your power. So this top number will be your power, or exponent. This one here will be your index right here. So this is like the cube root of a all to what power, kids? All to the 2nd power. Okay, so as an example down here, 27 to the 2/3, kids. Here's what this is saying. This is saying 27 to the 2/3 power. Whoops, I screwed that up. 27 to the 2/3 power. What number is your index for this? This is the same as which root then? 3rd root of 27, all to what power? Okay, let's just do this part right here first. Find the cube root of 27 for me. It's 3, isn't it? So this part in parentheses is what value, kids? It's 3. So this really becomes 3 to what power now, kids? 3 to the 2nd, which is going to turn out to be, careful, 3 squared would be 9, yep. Okay? You're going to end up with 9. Let's try another one. In fact, I think I've got examples on the next page. What you need to understand about rational exponents, kids, is the number in this fractional exponent, the denominator is your what? Index, and then the top number is like your power. So let's try a few of these, okay? Where are we at? 3rd page already, guys? Woo! Flying right along. Oh my goodness gracious me. Evaluate 243 to the 2/5 power. What? Okay, which number is your index?
5.
So this is going to be the 5th root of what, kids?
243.
All to what power? Okay, you guys find the 5th root of 243 first of all. By the way, is that index odd or even? So if I have an odd index, it can only be how many solutions? 1. 5th root of 243, are you finding that yet?
3.
How many agree 3? Or how many are getting 3 when they look for the fifth root of 243? Give me a show of hands if you got 3 for that. Okay, so this is really 3 to what power now, kids? And what's 3 to the second again? 9, yeah. Okay. Now part B, I want you to be kind of careful on part B. Okay, what's your index in part B? So this is going to become which root? Square root of all to what power? Okay, I want you to be careful on this. Think about the square root of 16. First of all, is my index odd or even? Even. I'm taking an even index with a positive number down here. So really, how many solutions does this have? Okay, this could be the same as, this could be the same, well, what is the square root of 16, I guess, kids? This could be the same as positive 4 to the third power, or what else is the square root of 16? What else works? Negative 4. Yep, I have this even index and a positive number down here. Or this could be negative 4 to the what power? Okay, well, guys, what is 4 to the third up top? 64. 4 times 4 times 4 would be 64. But what about that negative 4 to the third? Do we understand why we're looking at 2 solutions here, possibly? Because I have an even index up here of a positive, the square could either be positive 4 or negative 4. Positive 4 to the third, 64. But what about negative 4 to the third? Negative 64. So guys, my answer in the end for this could either be plus or minus what? 64. So that one's kind of a tricky one, all right? The key thing to take away from rational exponents, when I say rational, I'm kind of like talking about a fraction. The bottom number is my what again? Index, and then this is like the exponent, okay? The bottom number is the index, the top is like your exponent, all right? You guys ready to try one on your own?
No.
Everybody has to get this right. Go. Everybody get that right. This is kind of a tricksy one. I want to make a math rap and TikTok to it. It's not cool. You know what we're going to call it? The radical exponent. Pretty cool name, isn't it?
Yep.
Y'all wish you could be as cool as me. I know you're peanut butter and jealous. Let's try this. I need some talkers. I'm talking too much. I should do some more listening, right? Listening is good. Anybody want to talk me through this? I need a volunteer. Help me. Mr. Sam, I'm listening, kiddo.
So 3 is your index.
Okay, so I want a 3 with a radical sign here. What's going to be the value under the radical?
Negative 27 in parentheses
Okay.
to the second power.
Let me ask everybody this question. How many agree with this start right there? Sam, proceed, buddy. Good start.
Then you take the whatever what do you say?
So we call it the third root of negative
Third root of
27.
negative 27.
Yep, what'd you get there?
-3.
-3, very good. Now, by the way, since my index up here is odd, how many solutions are we kind of working with?
1.
Okay, so this becomes, I'll move this up here, the third root of -27 is -3 all to what power? Okay. Carry on, you're doing great.
And then you evaluate that, and it's 9.
Positive 9, because -3 times -3 would turn out to be what? Positive 9. Now I have a question. How many of you guys had -9 down maybe for a solution? Did anybody have -9 down? How many had +9? Okay. How many are on board with Sam's explanation? Like, yep, I think that sounded good. Sam, pat on the back. Good job. I think 9 is correct. All right, well, let's jump into these last two real-life examples here. I think we've got a pretty good handle on this. The nth root of something, I think we know when there's two solutions and one solution. I feel good about the rational exponents in terms of what's the index and what's the power. So let's apply this. Example 4, solving a real-life problem. How about I volunteer to read that for me there? Anybody want to volunteer to read that problem for me? I'll read it. It says the radius r of a what? Sphere is like the shape of a ball is given by the following equation. R is equal to 3 times v divided by 4 pi, where v is the what? Volume of the sphere. Down here they tell me the volume is what value? 463 cubic inches. It says find the radius of the basketball to the nearest what? Inch. Okay, so we have this formula for a radius right up here. Okay? We can find the radius if we know the what? Volume. So let's try this. All right. We know that the radius is equal to 3 times v all over 4 times pi. And it says use what for pi down here, kids? Okay. Now, kids, I know you have a pi button in your calculator, right? The only time I don't want you to use your pi button is when they tell you to plug in what value. Okay, if it doesn't say plug in 3.14, then what button are you going to push? All right. So I'm going to go 4 times 3.14. Well, kids, what is your volume? Okay, so to find that radius r, what am I going to have to plug in for volume? Okay, and then this is all to what power, kids? 1/3 power. All right, let's do this. I'm going to write this down. This is going to become 3 times what value? Yep. Over 4 times 3.14 all to the 1/3 power, like that. Okay, so wait till you're caught up there. All right, who has a calculator for me? We want to punch up 3 times 463 up top.
1,389.
1,389, Sam?
Yep.
Okay, got 1,389. This, what's 4 times 3.14 in the bottom? You get 12.56 for that? This is all still to what power, kids? Okay? All right, here's what I want you to do. In your calculators, first of all, divide this out for me. And we'll go 2 places. What's 1,389 divided by 12.56? 110.589. So is it okay if I call it 110.59? Okay, but this is all to what power, kids? But since it's to the 1/3 power, really, what is your index now out here? And then the power is 1, so I don't really need to worry about. So I'm really looking for the 3rd root of what value here to find your radius, kids. Looking for the 3rd root of what value? Yep, so you're going to go cube root of 1 110.59 in your calculator, and I think it says round to the nearest inch. We'll go, see what you get for a decimal first. 7.99? 4.799. So about 4.8 inches, which would round up to what? Nearest inch? Okay. Okay, now guys, was there a lot of calculating there? The answer was yes, but really we just had to plug 463 in for V. We had to calculate some numbers. And since this was to the 1/3 power, once I got down to this 110.59, we said, ooh, that's to the 1/3 power. That's like finding which root. The third root. Okay? Let's try another one here. Any questions on that example about what we did? It's a lot of number crunching, wasn't it? Okay. Well, I like this last example. It says to calculate the annual inflation rate. Do you guys see a formula in there again? In decimal form of an, what is inflation, by the way? What is inflation?
Like a money?
Yeah.
Like increase of the value?
Yeah, it's like an increase in stuff. So inflation means like rising prices. Okay, so like when you guys graduate school, get through whatever you're going to do and start a job, do you think you're going to make the same amount of money every year, or are you going to make more and more year after year after year, hopefully? And that's to say to adjust for the cost of living or inflated prices. All right. So here's the deal. The annual inflation rate R of an item that increases in value from P to F over a period of n years. So it started at price P and went to what? Price F over a period of n years. It says you can use the following equation. R equals F over what? To the 1 over minus what? Okay, it says find the annual inflation rate to the nearest 1/10 of a percent of a house that increases in value from, okay, what did it start out as? And then over time it went up to a value of, and how long did it take that time to appreciate? 8 years. Okay, we need to plug in stuff. So we've got to find this annual inflation rate, R. R is going to equal, okay, so we start at P and go to F. So F is like my ending price. So what's the ending price here, kids? So in for F, we're going to plug in what? 360,000. What was F, kids? 300,000. Okay, this is going to be to the 1 over n power, which would be 1 over what, kids? 8 years minus 1. Okay? All right, somebody take that 360,000 and divide it by 300,000. So we've got R equals 1.2 to what power, kids? 1/8, but that's really which root, kids? 8th root, and then minus 1. So help me out, kids. I need someone to evaluate the 8th root. Let's go about 2 or 3 places on it. 8th root of 1.2. Now, guys, in this one right here, I want to stop. Because is the value of that house going up or is it going down? Now, I want you to be careful because what kind of an index do I have here? I have an even index, right? And a positive value, which would indicate to me how many solutions? 2. But think of it this way, all right? Are my prices rising or are my prices decreasing? They're rising. So if they're rising right here, then that means that your percent has to be what kind of a value, positive or negative. So I'm only going to worry about the positive one for this real life problem. Even though we know what they should be, how many solutions? Okay, what do you guys get for the 8th root of 1.2? 1.02 minus how much? What's R equal? 0.02, is that right? What would that look like as a percentage rate then? 2%. So the inflation there, so inflation would be 2% each year. Okay. So kids, what I would encourage you to do, take a look at your notes. I'm going to send out an online book page here right now. But I think, guys, I really think that this is pretty manageable. Would you guys agree with that? Okay. All right. Tomorrow. Guess what tomorrow's going to be for you guys? A lot of time to work on things. Okay, I'll have some stuff for you tomorrow. I'd say if you can get started on the online tonight, that might be good. Come with questions first thing tomorrow morning. Don't forget to be checking JMC. Everybody cool with that? See where you're at. That's up to date right now. So know what your grade is. And if you're comfortable where you're at, good. If you're not comfortable, come see me. We'll see what we can do.